In this example, we're supposed to write the mesh equations, find I1, I2, power at resistor R2, power at resistor R3, and voltage at resistor R6. First, we have to always set up the loop currents. We assume that the loop currents will go always in clockwise direction, and this is my loop 1 and this is my loop 2. That's why I'm going to call this current I1, and this current in this loop is going to be called I2. Keep in mind that this is the general formula for the mesh equations for two-loop diagram. Okay, we have two loops, loop 1 and loop 2. First, we have to find Z11. Please keep in mind that Z11 is the sum of all impedances in loop 1. So I have R1 plus R2 plus R3. The sum of all these impedances, I supposed to say resistances in this loop, is going to be my Z11. I have R1 2 kilo plus R2 3K plus R3 4K. This is equal 9K. I found Z11. Next, I have to find Z12. Z12 is going to be equal to Z21. This is the impedance between these two loops. Between these two loops, we have resistor R2. That's why I'm going to write that Z12 is equal Z21, and this is equal R2. Keep in mind, this is the impedance between these two loops. Z12 is impedance looking from loop 1, and Z21 is impedance if you look from loop 2. This is the same resistance. Is equal 3 kilo. Z22 is the sum of all impedances in loop 2. I have R2 plus R4 plus R5 and plus R6. This is equal 3K plus 5K plus 5K plus 3K. This is equal 16 kilo. Next, we're supposed to find the sum of the voltages in loop 1 and the sum of the voltages in loop 2. Please notice that in loop 1 we do not have any voltage source. That's why I'm going to write that the sum of the voltages in loop 1 is equal 0 volts, because I have no voltage source in this loop. Next, I have loop 2. You have to look at the direction of the loop current, and you have to look also at the polarity of the voltage source. Keep in mind that we use the conventional current flow, and we assume that the voltage source is going to push the current from positive terminal to negative. Next, you're supposed to compare the directions of these two currents. If the directions of these two currents are the same, means they are going in the same direction, your voltage is going to be positive. If they are going to oppose each other, you're supposed to write negative sign next to given voltage source. So in this case, I have some of the voltages in loop 2. I have just one voltage source, and these two currents are going the same direction. That's why I'm going to say that the sum of the voltages in loop 2 is equal simply positive V1. Why? Because these two currents are going the same direction. If they would oppose, you were supposed to write negative sign, but because they are going the same direction, you keep this positive. And this is equal 24 volts. Now we are ready to write the mesh equations. This is the general formula. I'm going to write the first equation. I have I1. We found that Z11 is equal 9 kilo minus I2. Z12 is equal 3 kilo equals the sum of the voltages in loop 1 we found is 0 volts. This is my first mesh equation. Let's do next one. I have negative. This negative comes from the formula. I1 and Z21 is equal 3K plus this positive comes from the formula I2 and Z22 we found is equal 16K. The sum of the voltages in loop 2 is equal 24 volts. These are the mesh equations. Next, we're supposed to find the loop currents I1 and I2. Like before, we are going to use determinant to find these two currents. First, we have to find delta. Delta is determinant from integers which are next to my currents I1 and I2. So I have Z11 minus Z12 negative Z21 and positive Z22. Again, someone can ask why I have negative. I simply copied down this negative. Negative Z12 and negative Z21. I'm going to replace these by the values. I have 9K minus 3K minus 3K and I have 16K. I have to solve this determinant. This is going to be equal 9K times 16K minus negative 3K times negative 3K. This is equal 135 mega ohm square. Kilo times kilo gives me mega. Ohm times ohm gives me ohm square. Remember, anytime I do not write omega ohm, I simply just keep in mind that anytime I talk about the resistance, of course, I have to talk about ohms. In order to save the space on the board, I just ignore ohms. So we get 135 mega ohm square. Now we can find NI1. NI1 is the number which helps me to find current I1. Please keep in mind that anytime looking for NI1, you're supposed to replace the first column of your delta by the constants. Some of the voltages in loop 1 and some of the voltages in loop 2. That's why I'm going to write over here some of the voltages in loop 1 and some of the voltages in loop 2. And I'm going to copy the second column from my delta, minus Z12 and Z22 equals. I'm going to replace the variables by the values of my resistances and voltages. So I have 0 volts and I have 24 volts and I have minus 3K and I have 16K. This is equal, and I have 0 volts times 16K, 0 times 16 minus negative 3K times 24. This is equal 72 kilovolt ohm. Kilo because I have kilo, volt because I multiply ohms by volts. That's why my unit is kilovolt ohm. Next, I can find I1. I1 is NI1 divided by delta. NI1 we found is equal 72 kilovolt ohm over delta, which is equal 135 mega ohm square. Ohm and square will cancel out. Volt divided by ohm gives me amp. So I have 72 kilo divided by 135 meg is equal 533.33 microamps. This is my current I1. Now we are ready to find current loop I2. But first, we're supposed to determine the number Ni2. So Ni2, I'm going to find from the determinant. The first column in my determinant is going to be exactly the same like in delta. Z11 and negative Z21. The second column is going to be made from the constants, some of the voltages in loop 1 and some of the voltages in loop 2. I'm going to replace the variables by the numbers, and I have 9 kilo, 3 kilo, 0, minus 3k, 0 volts and 24 volts equals, solve the determinant. You have 9 kilo times 24 kilo minus 0 volts times negative 3 kilo. This is equal Ni2 is equal 216 kilovolt ohms. Now I'm ready to find I2. I2 is Ni2 divided by delta, which is equal 216 kilovolt ohm divided by delta, and delta is 135 mega ohm square. Ohm and square will cancel out. Volt divided by ohm is amp, so 216k divided by 135 meg is equal 1.6 milliamps. This is my current I2. If we have current I1 and I2, two loop currents, we can find the following quantities. Now, we have to find P R2, power at resistor R2. Remember that formula for power says power is equal I square times resistance. So, in order to use this formula, we're supposed to find the current which goes through this resistor. Please notice that by this resistor, two currents are going to flow, I1 and I2. And also, please notice that these two currents are going to oppose each other at this resistor. I1 is going to go from the top down, and I2 will go from the bottom to the top. They're going to oppose each other. That's why I'm going to subtract them in order to find the current which goes through resistor R2. So R2 is I1 minus I2. One more time, because they're going to oppose each other. They're going to oppose each other. So if I1 we said is equal 533.33 microamps minus I2, which is equal 1.6 milliamps. This is equal negative 1.06 milliamps. We got negative current. Please keep in mind that our reference current is I1. If you got negative value of the current which goes through this resistor, it means that the current, the real current, is going to oppose I1. Why? Because I have negative sign. This is my reference current. So if I got negative value, the current which will go through this resistor, in reality, it is going to go up. So I got the current. If you want to find the power at resistor R2 is equal IR2 square times R. We found that IR2 is equal negative 1.06 milliamps. We have to square it and multiply by this resistance. This is R2, of course, 3K. Power at resistor R2 is equal 3.37 milliwatts. This is the power at this resistor. Next, we're supposed to find power at resistor R3. P R3. Again, I'm going to use the same formula. Power is equal current squared times resistance. Please take a look at the diagram and notice that the current which will go through resistor R3 is the current I1. Okay, because I1 will go by R3 and R1. R2 is going to have the combination of I1 and I2. That's why I'm going to use current I1 in order to find power at resistor R3. So this is I1 square times R3, which is equal, I1 we said is equal 533.33 microamps square times the resistance R3, 4 kilo. This is equal 1.13 milliwatts. This is the power at resistor R3. Next, we're supposed to find the voltage at resistor R6, voltage across the resistor R6. Keep in mind that Ohm's law says voltage is equal current times resistance. So in order to find VR6, I have to multiply I2 by R6. Why I2? Because current I2 is going to go by resistor R4, R6 and R5. Keep in mind R2 is going to have the combination of these two currents. That's why I use only I2 to find VR6. I2 we said is equal 1.6 milliamps times R6, which is equal 3 kilo. This is equal 4.8 volts. we got all answers for this problem.